Just take a look around you for a second. Your phone, your car, maybe even the cup you're drinking out of. We see all these things as, physical objects, but their story? It doesn't actually start in a factory. Nope. It starts in this totally invisible world made of pure data. So today, we're going to pull back the curtain on the digital factory and see how computers are the secret architects behind almost everything we use every day.
So how did that coffee mug get into your hands? It's pretty easy to picture some noisy factory floor with sparks flying everywhere, right? But that's only like half the story. The real journey began way before that, as a silent stream of ones and zeros inside a computer. We're going to trace that digital DNA from start to finish. Every single physical product starts its life as a ghost. It's just an idea, a concept. But before even one piece of metal gets bent or one piece of plastic is molded, that ghost has to be given a real form. So welcome to part 1, the digital blueprint. This is where ideas get hammered into reality, all inside the memory of a machine.
Okay, this is the command center, the brain of the whole operation. It's called research and development, or just R&D. Think of it like a digital playground where engineers can just go wild. They can test the absolute limits of physics, dream up these crazy new designs, and basically break things over and over again without any consequences, all before spending a single penny on real-world materials.
So how does this digital playground actually work? Well, instead of crashing, say, a dozen real cars into a wall, which is super expensive, engineers can crash 1 million virtual ones. They can simulate a whole decade of wear and tear on a new phone in just a few hours. This constant cycle of simulation and then analyzing all that data lets them just iterate and tweak endlessly, perfecting a design before it ever leaves the computer screen.
All right, so the design is perfect. It's amazing. But it's still just a file sitting on a computer. How does it become a real order? A command to actually build something. Well, that happens through digital documentation. Every one of those complex designs gets translated into technical specs, supply chain orders, and even legal contracts. It's the digital paperwork that officially gives the blueprint the green light.
Okay, the blueprint is approved. The order has been sent. Now we enter part 2, the automated factory. I want you to forget those old images of dark, greasy workshops. This is a clean, humming ecosystem where our digital instructions finally meet the physical world.
The modern factory is really like a digital symphony, and it's in 3 parts. First, the system has to orchestrate the arrival of every single part, right on cue. Then, these amazing robotic arms perform the assembly. And finally, you've got a digital conductor overseeing the entire process, making sure every single movement is perfectly in time.
It all kicks off with the parts. Material and inventory management systems are the logistical geniuses here. And they're not just tracking boxes in a warehouse. They're running what's called a just-in-time operation. This means they make sure that the exact screw needed for step 57 arrives at the assembly line literally seconds before it's needed. No waste and no waiting around.
And now, meet the muscle, the robots. These aren't just clunky machines. They're basically physical avatars for our digital blueprint. They take the code that we wrote and turn it into actual motion, welding, lifting, placing, all with a level of precision that never gets tired, never wavers, and definitely never needs a coffee break.
And the work they do is incredibly diverse. One robot might be the backbone of the assembly line, just placing tiny components with surgical accuracy. Its neighbor could be a master welder, handling jobs that are way too dangerous for humans. Then further down the line, another robot applies a completely flawless coat of paint, and the last one carefully packages the final product for its journey over to you.
But with thousands of parts moving at super high speeds, who's the conductor of this whole orchestra? Well, that's process control. It's basically the factory's central nervous system. It's this whole web of sensors monitoring everything, from the temperature of a welding torch to the speed of a conveyor belt. And it's making thousands of tiny adjustments every single second to keep the entire symphony in perfect harmony.
So the assembly line is humming along, but a factory runs on more than just electricity, right? It runs on people and it runs on money. So for part 3, let's head on up to the command center, the digital back office that manages the human and financial engines of the whole operation.
First up, the people. Human resource, or HR, applications are the digital tools that manage the entire life cycle of an employee. From finding the perfect engineer for the job to making sure they're on the factory floor at exactly the right time, these programs organize the most valuable asset any company has.
These systems are really the digital backbone for the human side of the company. They handle, pretty much everything.
scouting and recruiting new talent, keeping all employee records safe and digital, and tracking daily attendance to make sure that complex dance on the factory floor is perfectly staffed at all times. Of course, none of this happens for free. Accounting and financial apps are the lifeblood of the operation. You can think of them as the digital guardians of the company's money, meticulously tracking every single transaction to make sure the entire business stays profitable. And their scope is just massive. They manage payroll, making sure thousands of employees get paid correctly and on time. They process this constant flow of invoices, both paying suppliers for materials and billing customers for the finished products. And, critically, they provide all the data for budgets and financial statements, which is basically the ultimate report card on the company's health.
So our product has been designed, it's been assembled, and the books are all balanced. We are in the home stretch. But now comes maybe the most critical test of all: quality. Welcome to Part 4, the final polish, where we make sure our creation isn't just built, but that it's built perfectly.
The key to perfection has a name you might not have heard before: metrology. It's the science of measurement, but it's been elevated to a total art form. Using things like lasers and high-speed cameras, computers scan every single millimeter of the finished product, comparing it against the original digital blueprint to hunt for any deviation, no matter how tiny.
And how tiny are we talking? Look, we're not talking about close enough. The goal is often 99.999% accuracy, a standard they call 5 nines. What does that even mean? Well, for something like a car door, that's a tolerance smaller than the width of a human hair. That is a level of perfection that is physically impossible for a human eye to see, but for a computer, it's trivial.
So why this obsession with precision? It all comes down to one thing: quality control. This final digital check is the company's guarantee to you that the product you're holding in your hands is safe, it's reliable, and it performs exactly as promised by that very first digital blueprint. It's the ultimate seal of approval.
And just like that, our product's journey is complete. It went from just a spark of an idea in the digital blueprint to the amazing symphony of the automated factory, through the essential management of the command center, and finally, it was certified perfect by the final polish. And at every single one of those steps, a computer was the silent, absolutely essential partner.
So this digital factory has built our modern world. But it does leave us with a pretty mind-bending question. Everything we've seen today involves computers following instructions. So, what happens when they start writing them? What happens when the factory itself begins to think? Let me know what you think. Thanks for exploring this with me.